Reciprocity theorem.
Welcome to another episode with King Solomon and Kozi. So we've already done theory theorem, we've done superposition theorem, Thevenin theorem, Norton's theorem. So the last theorem we are going to talk about is reciprocity theorem. When we talk of reciprocity theorem, let's take this analogy. It's in a linear bidirectional single source network. So we are talking of a single source network. So we can take a network like this with a voltage source. Then this network is connected to a larger network. So this is a bigger network, which is made up of resistors, capacitors, and so on. And you have another side which we can call this branch A. In branch A, you get a current coming this way. So this current becomes the response of this voltage source. So if this is VA or this is VB, the current in branch A will be IA. So what we are going to do is that they said in a linear bidirectional single source network, the ratio of response. So this is our response, IA. IA to excitation. The excitation is the source that is producing the IA. So in this case, it is going to be VB. So the ratio of this remains the same when the position of the response and the excitation are interchanged. So meaning if we exchange the source and the current source, maybe there is another voltage, there is the same network, but they've decided to change the value of the battery. So assuming this one it was 30 volts and it is producing 5 ampere current, and they exchanged the battery, and this time they brought it here, and instead of the 30 ohm, they are saying that this is now 100 volts. So, and they want us to find the response of this 100 volt. What reciprocity theorem is telling us is that the response or the ratio is going to remain constant. So it means if you pick this 30 on 5, or we take the current first. So if you pick 5 on 30, if you come here and you want to find I, you know I will be over 100. And these two terms must be the same, provided the network we are talking about is the same. So if the network we are talking about is the same, then you can equate them and simply get I. So that is what reciprocity theorem is talking about. But there are some conditions. If those conditions are not satisfied, you can't apply reciprocity. So these conditions are as follows. 1. The ratio of response to excitation can be ohmic or mole. The ratio of response to excitation can be ohmic or mole. So, like in this example, because it is I over V, it is mole. But if it was to be V A over I B, it would have been ohmic. So that is what we have over there. And the second condition is that, as we said here, the circuit must only have one independent source. The circuit must have only one independent source. And the circuit must not contain any dependent source. any dependent source. So these are the three conditions that must be satisfied before you can use reciprocity theorem. So let's pick an example. So in this example, we give us a battery and we have a resistor here. We have another resistor. And the voltage here is let's take it as 50 volts. And they told us that this is R1, R2, R3. And the current here is 4 ampere. So then the question has another circuit. But this time the voltage source is here. And this is the current. And we want to find this current. But the voltage source has been changed from 50 to 250 volts. And now we have our resistor. We have our other resistor. And we have our last resistor. So this is our R2, R1, and R3. So they want us to find I. But they will give you this circuit before always this circuit. So somebody will say that since I don't know R1 and R2 and R3, you can't solve this question. But first, just consider the condition. Is the reciprocity theorem being obeyed? If it is being obeyed, we can just use reciprocity to solve this question within a minute. So let's see. First, they said the ratio of response to excitation can be ohmic or mole. That one. If the other two conditions are satisfied, you will come and see if that is true. Then they said only one dependent source. So if you come here, you can see only one dependent source. There is no other dependent source. A, there is only one independent source. There is no other independent source. And there is no dependent source in this circuit. So it means we can apply the reciprocity theorem. So when you come to this circuit, they are telling us that the response is 4. So you have 4. And the excitation, the one producing this 4 ampere, is 50. So that's the ratio of response to excitation. But if you come here, the response is I. And the excitation is 250 volts. So what they are telling us is that if the ratio always remains the same. So if the ratio is going to remain the same, it means you can equate this to this. And if you have to equate, you get I over 250 is equal to 4 over 50. Now you can multiply both sides by 250. And this cancels this. Then you end up getting I is equal to 50A1, 50A. This is going to give you 5. And 5 times 4 is going to give you 20 ampere. So it means in this circuit, the I that they are expecting us to find is 20 ampere. So thank you for being with us on reciprocity theorem. Meet you in the other video for star delta transformation.